first is nature, the second is nurture, and the third is the investigator. So nature, nurture, and investigator. So nature is when the treatment is assigned by God, or you were born, or whatever supernatural force you believe in, right? So think of an incident like, or a scenario like, oh, you were born a certain way. Well, you actually nobody had control over that. So you can say nature was the one that assigned you into that category. So if you are doing a study of, let's say, um, racial identity, or racial classification, and let's say hypertension. Well, in this case, the investigator is not the one that assigned people into being black or into being white. That assignment was done by nature, right? So in that case, whenever assignment is done by nature or by nurture, we say that is an observational study, because we just met it that way. We did not assign the treatment. We're just observing based on what was already pre-assigned. So nature could assign treatment. The same thing that happens to if we're talking about, let's say we're looking at the relationship between place of birth and certain outcomes, all right? The exposure variable here is your place of birth. The investigator was not the one that said, hey, you are going to be born in Nigeria and you are going to be born in Switzerland. No, the assignment was done by nature. So that in that case, the investigator has no control over that. So that's the first entity that can assign treatment. The second one is nurture. Nurture has to do with our environmental factors, right? So it's no longer genetic per se, but it's now how the environment interplays with whatever genetic factors we have. So when you think of nurture, you think of things like where you live, where you work, where you play, the kind of food you eat, how you take care of yourself. So if I'm doing a study again, and we're looking at the relationship between let's say weight, right? Weight and, let's say, certain health outcomes. Well, it wasn't the investigator that assigned certain people to be obese or to be underweight. That is nurture. That's how environmental factors, including how we take care of ourselves. But in that case, nurture, or how we take care of ourselves, our environment, our food, and every other thing, influenced which category we belong to. It wasn't the investigator, right? Or think of something like academic performance. And if you're doing the study on academic performance and, let's say, some outcomes in the future, in this case, you're looking at people who have good performance or bad performance. Again, it's not the investigator who assigned you into treatment, into saying you are going to be a bad performer and you are going to be a good performer. The investigator simply met you that way, right? And that is why we say it's an observational study, because they are not the ones that said you will be in this group of poor performance and you will be in this group of good performers, right? They met you that way. So observational studies are simply studies where the investigator simply met the groups the way they are. And all they can do is just observe, right? That's why we call them observational. The assignment into groups was already done by either nature or nurture. And the poor investigator simply came and just met them that way. And it's just documenting what they saw, or seeing how which group you belong in influences some downstream outcome. But then there's a third category where sometimes the investigator will assign people into treatment, right? Now, that is what we call an experiment, because now the investigator came and said, you, and you will belong to this group, and the rest of you will belong to this group. Now, that is what an experiment is. So sometimes when people think of experiment, they think of some fantastic scenario in the lab where people are wearing, lab coats and pouring some chemicals. Well, that's an experiment too. But we also have experiments at the population level where we the investigators, assign people into groups. Another name for an experiment is also called an interventional study, right? And that should be very obvious from the name. It's interventional because we are intervening. We didn't just meet them that way. We actually came and intervened and said, you, and you will belong to this group. The rest of you will belong to that group. So that's why it's called interventional, as opposed to observational. Observational is passive. Interventional is active. We're the ones assigning people into groups. And the reason why observational studies at the bottom and interventional studies at the top in terms of internal validity is because just by randomizing, of course, we already established that not all experiments are randomized. You can have non-randomized trials. But in this case, well, the one at the top here is randomized clinical trial. So we are focusing now on when there is randomization. When you randomize people into groups, that takes care of both known and unknown confounders. In epidemiology, we're always worried about confounding. Confounding is like, it's like a thief. You can think of confounding as a thief that comes in and steals. They steal value. In this case, think of a causal pathway. If we talk about the relationship between, let me take a screenshot. If we're looking at the relationship between, let's say A as the exposure variable and Y as the outcome variable, now A as exposure really, really wants to own all of the explanation for why Y exists. That's kind of a tongue twister, right? A wants to be the sole entity that explains why, we observe certain things according to Y. Now, the confounder here, let's call it X, comes in and steals value, right? And tries to explain some of the things that are happening with Y, so that we can't really say that everything that occurs in Y is attributable to A, because we have this thief that has come in now and is stealing some value, some explanatory value from A. So a confounder is a variable that is associated with the exposure and with the outcome and does not lie on the causal pathway. So if you're doing a study, for example, on, let's say, the relationship between diet and mortality, right? If your study is, let's say, if most of the people who are in one arm are also very rich, you can say, well, it's not just the diet. They are very rich, so they also can afford better things. They can afford better healthcare. They generally have a health conscious nature, if they're younger people or workers, you talk about a healthy worker bias, right? People who are healthy, who are young, also working, going to the gym and all of that. So not all of the outcome is attributable to the exposure, right? We want a scenario whereby we create a study that takes care of all confounders, right? The beauty of randomization is that the confounders that we know and the ones that we don't know of are both taken care of by confounding. When we randomize people to groups, if the randomization is done properly, it addresses both known and unknown confounders. And that is why the internal validity of randomized trials is very high, right? Internal validity simply means, think of internal validity like a shield. Like if think of, now everybody's talking about Gladiator, right? Gladiator 2. Think of the Roman armies where you would need to have a very large shield that protects you from the arrows of the enemy. So internal validity is saying, how big is this shield that we have that protects us against threats to validity? Threats to validity includes, things like bias, like selection bias, confounding bias, right? So the larger the shield, the more protected we are from those threats to validity. And so that's essentially why experiments are very important, because they provide the absolute, well, not absolute truth. Experiments also get things wrong, but relative to the other studies, they're the best source of truth, right, in terms of internal validity. So this is how we can also classify epidemiologic studies. If you've attended our classes, we've looked at this flow quite a number of times. So you start by asking yourself, are groups being compared by exposure status, right? So are we comparing two groups by, let's say, exposed or non-exposed? If you are, then you say the study is analytical. So analytical studies are studies where you're comparing two or more groups, right? If it's not analytical, then that means that it's descriptive. So that's the highest level of classifying studies. Is it a descriptive study or is it analytical? You can also think of analytical studies like comparative studies. Then once we've established that it's analytical, the next question is, who made the assignment? Was it the investigator, or was it nature or nurture? If the assignment was done by the investigator, we say it's interventional, which is also called an experiment. However, if the assignment was done by nature or nurture, then we say that the study is observational. So case control studies and cohort studies are examples of analytical studies that are observational in nature. Can that person please stop making lines on the screen? And then lastly, if we now know that the study is interventional, then the next question is, who was the assignment done at random? The groups we're talking about, were these individuals assigned by random? If they were assigned at random, then we say that is a randomized controlled trial. If it's not done at random, then we call that a non-randomized trial. Now, for those of you who are interested in careers in epidemiology, if you go to LinkedIn and search for jobs in pharma, you see a lot of jobs, like a class of jobs called real-world evidence, right? Real-world evidence essentially has to do with evidence outside of a clinical trial, right? And so there are some minimum competencies that you should be very, very proficient in. One of these should be pragmatic trials. So pragmatic trials will be trials that are not necessarily randomized, like single-arm trials, for example. Those are pragmatic trials that are not necessarily, randomized, and they fall under the realm of real-world evidence. You will also need to have a lot of knowledge about this arm of studies too, observational studies that are of analytical nature. And of course, there's also some descriptive studies, especially using claims data, right? Another, large national data sets. That is extremely important if you want to make a career in this space of real world evidence. But anyway, I digress. Let's go back to our topic. So in general, experiments tend to be longitudinal, but it's not always, right? Remember that the only thing that makes a study an experiment is not whether it's longitudinal. It is whether the investigator assigned people into groups or not. That is what makes an experiment. So it's not whether we follow people over a long period of time. It is whether or not the investigator assigned people into groups. Because think of it, right? Why are we following people for a long time? Well, we're following them because we're trying to track the outcome. Now, the next question is, why do we need to track people for such a long time before measuring the outcome? Well, the answer is because it takes a long time for the outcome to develop. If we're looking at, for example, the relationship between, let's say, a particular treatment and mortality, well, it takes a long time for people to die. People don't just fall down and die. It takes time. You follow them, and then you observe the outcome. But what if our study was not necessarily a dramatic outcome like that? Maybe it was not even a behavioral outcome. Maybe our study was more of a cognitive outcome, right? Like, how are you thinking? Like, what do you think of this? Well, in that case, the outcome is almost instantaneous. Like, I randomize people into viewing this object or viewing that object, and then I ask them, what do you think about this? In this case, the outcome is occurring instantaneously. It's a belief, it's a cognition, it's a perception. I don't have to track people over a long period of time before I can capture the outcome, right? And so it's also appreciating the nuances of this and knowing that you can capture data in one single snapshot in time, and it could still be an experiment. What matters is that the treatment was assigned by the investigator, right? So this is why we need to know the nuances of this. And once we know all of this, it's the way we design studies can then dramatically change. We can then think of ways where we can consolidate, we can have nested designs. So even in a cross-sectional survey, we can choose to nest an experiment inside the cross-sectional survey. So imagine you have a survey of questions that are in general descriptive, but then you come to a particular question where you can say, oh, I want to randomize these participants. Half of them will be randomized to viewing this particular intervention. The other half will be randomized to seeing that intervention in the context of this cross-sectional survey. So all the other questions are descriptive, but that particular question is an experiment, because in this case, you are assigning people to, being exposed to one thing or to the other thing, right? And that is what makes an experiment. So this is how you can then design studies that are extremely powerful, that answer very important questions without having to go and rob the bank, without, it's knowing what an experiment is and how you can think of it in ways that are non-obvious and that address, issues of importance in very innovative ways. Longitudinal studies, of course, talk about, a whole bunch of them. But again, just to establish that a study is an experiment, not that it's longitudinal in nature, but that it is assigned by the investigator. One of the reasons why experiments are very important is because they are hypothesis confirming studies. One way we can also classify all epidemiologic studies is whether they are hypothesis generating or hypothesis confirming, right? Hypothesis generating studies are generally observational studies, or that cannot definitively say that A causes B, right? For us to say that A causes B, there are very important criteria that we have to check off the list, right? I'm sure we're all familiar with Hill's criteria. Hill's criteria is a framework that allows us to evaluate issues of causality, right? And descriptive studies simply cannot establish, causality because they are limited by so many constraints. So that is enough framework, and this is why experiments are also very important, because they allow us to evaluate hypotheses that have been generated by previous descriptive epidemiology or descriptive studies, and to be able to confirm them. Now, obviously, not all experiments are hypothesis confirming. We must make that very clear. If you think of the life cycle of or the phases of a clinical trial, for example, the only phase that is definitively confirming is phase 3. That's what we also call phase 3 studies, confirmatory clinical trials, right? We add that word confirmatory because the phase 3 studies are uniquely designed to confirm hypothesis. You can't say that about phase 0, phase 1, or phase 2, or phase 4. Phase 4 studies are also just observational. They are post-marketing studies. But phase 3 trials are designed specifically to confirm hypothesis. All right, we're talking about internal and external validity. So let's clarify what they mean. External validity is truth in nature. All right. Truth in nature, in other words, how generalizable are these results. Internal validity is truth in the study. So the analogy I often use is, well, you want to get married to somebody and you're like, okay, can we just make sure that we are internally compatible, that we like each other, that we can live together, that we can have children? Do you have STDs? Are we resource compatible? Right? All of that is checking internal validity, right? And then you say, okay, let's take you to meet the family. Does the family like you or not like you? Now that's external validity, right? You're trying to see how generalizable that particular scenario is. So you can see that it's possible for you to have internal validity, but not external validity. This person could be, you guys could be soulmates, but the family does not like the person, right? So it's possible that a study could have internal validity, but not external validity. It's also possible that the study could have significant external validity, but have, minimum internal validity. The family likes this person, but, well, there are just some issues that you have between the two of you that makes you less than ideal. So in the same vein, we're going to have, let's say, cross-sectional studies that are designed to be representative, have high external validity, but do not have very high internal validity because they have threats to internal validity. For example, issues of temporality and so many other things, means that there is just a limit to which we can use them to answer key questions. And of course, it's very apparent also that you can have studies that have low internal validity and low external validity, right? You guys have issues between the two of you, and the family does not even like the person anyway, right? So you can think of like convenient samples. Convenient samples may not necessarily, depending on how data are collected or captured or how things are measured, may have low internal validity and also have low external validity. So we need to know the difference between those two things. Cross-sectional studies, well-designed representative cross-sectional studies typically have very high validity. external validity, but low internal validity. Randomized control trials tend to have very high internal validity, but low external validity. And this is because the way we recruit people into clinical trials is such that it's simply by volunteers. We put flyers everywhere and say, hey, do you have this condition? Do you want to sign up for this clinical trial? It's a bunch of volunteers. And that's why clinical trials, there's been this long complaint that there's underrepresentation of certain groups in clinical trials, like Blacks or other minorities. They just don't sign up for trials, and you won't blame them. There have been historical trust issues within the Black community, for example, and the world of research. And so that's why you find representation very low in those. So it's very important for us to know those differences, and also not just know them, right? As epidemiologists, we want to think of, all right, it's not enough for us to just accept that clinical trials have low external validity. What can we do to improve it, right? Do we have to change the way we sample people into those studies? Do we want to stratify on certain characteristics to make sure we have adequate representation? Do we want to use methodological issues to control or to adjust for the poor external validity? For example, can we use weights? Can we use, calibration? All of us. So it's not just about knowing passively and saying, well, what can we do? This is how these are the cards we have been dealt with. No, I mean, that's why we're experts. So the whole point of expertise is to say, all right, this is not acceptable. We can do something about it. So, but first of all, we need to know that that exists. All right, now let's see how we can design, let's go on the Chisquares platform and see how do we then design, what are some of the tools you have at your disposal to design experiments when using the Chisquares platform. But I want to stop there and see, first of all, if there are questions, if folks have questions before we proceed. Any questions? Just have been very quiet today. No? Thought I saw your hand raised.
Virginia, you can unmute yourself. Virginia, you can unmute yourself and ask your question.
Okay, thank you. Yes, initially I wasn't able to unmute. Good morning, everyone, and thank you so much for this lecture. I just want to quickly find out, I don't think I heard quasi-experimental. Please, can you throw more light into that type of experimental? Is it randomized? Can you classify it as purely randomized or non-randomized? I'm thinking it's non-randomized, but maybe just throw more light into it. Okay. Thank you so much. Yeah.
Yeah, thanks. So when we have scenarios like that, most of the things in research are self-explanatory when we look at the nature of the words, of the etymology of the words, right? In this case, the word of nature of importance is the word quasi. Who can help us explain what that word means? Any takers? None? We're very quiet today. What's happening?
Virginia.
Okay, can I just say what I think I know about it?
Yes, please go ahead. Yes, yeah.
Okay, for quasi, from the name, like you rightly said, is something that is not fully experimental. And until recently, I used to think, before I got to know there are even different types of quasi-experimental studies. But initially, I used to refer to them as pre and post, where you use the same individual, you're administering your study instruments, and then you do an intervention. You're measuring some parameters before your intervention, and then after your intervention, you measure. After your intervention, you now measure the same parameters and try to find out the effect of that intervention on the parameters. Do we have any decrease or increase in any of the things depending on what you are looking for? That's my understanding. But along the line, I got to know that there are even different types of quasi-experimental. So just to get more insights. Thank you.
Thank you very much. That's any other thoughts?
Please, if you want to speak, you can signify by raising your hand so I can unmute you. Okay. Fọlọ́runṣọ́ Balógun. Fọlọ́runṣọ́ Balógun, you can unmute now.
Thank you, and good afternoon. For quasi-experimental studies, it means there is no randomization. Many times it's the participants that actually go into those, they are the ones that like assign themselves. They're not assigned by the person conducting the research. That's my understanding about quasi-experiments.
Yeah, thank you very much. One last taker. Oh, move on.
Okay, we have someone raising hand. Oyidamola Samson, you can unmute yourself and speak. You can unmute yourself and speak.
It is always difficult. Can you hear me? It can
Yes.
be scary answering questions from Prof. I'm always scared so that I will not say the wrong thing.
No, it's fine.
I feel it is quite a manipulative independent variable. What I mean by that is that when a research is ongoing, the manipulation comes independently and to observe its effect on the dependent variable. So most of the times it basically lacks causal inferences, like it focuses more on causal inferences, like through experimentation, it's established causal relationship between the variables to be checked. So I hope this will help, and I hope Prof will help us more. Thank you, Prof.
All right, thanks. Well, why I still have you on the line. So what then is the difference between what makes them quasi? So that we all clear about that, right? What makes them quasi?
Well, number one, they behave independently for me, but they are not independently. It is like a mirage variable that wants to behave like an independent variable. And at the point, it focuses more on, let me put it that way, kind of showing that they are independently, but basically they still depend on some variable to.
Okay, thank you. All right, so if we go back to the beginning, right? Quasi experiments, are they observational or are they interventional? Because this is very simple, right? This our flow here says. So we all agree that they are analytical studies. I don't think there's any debate from anyone here about whether or not they are observational or whether they are descriptive or analytical. That's not a debate. The debate is on this part here. The debate essentially is, are they interventional or non-interventional? So let's start from there. Any thoughts?
Please, if you want to speak, you can raise your hand so I will unmute you. Okay. We have Abraham. Can you unmute yourself and speak?
Yeah, Prof, thanks very much. That's what I just wanted to say before the others came in. It's sandwiched between interventional and observational. It's not 100% interventional. To some extent, there's an intervention in it. But I think the other part is also observational. So it's kind of sandwiched between there's an intervention of some sort. And then the other arm too is like you are going to observe based on the intervention that you have put in place. So it's neither here nor there. That is from my opinion. But to some extent, there is an intervention.
So what's the difference? Thank you very much. And that's all good points. So what's the difference between a quasi-experiment and a cohort study?
A cohort study, it's more or less like a group of people with similar characteristics. That there is a starting point at a starting point, and you are observing them over a period of time. And alongside, others may drop off, others may, like in TB control, for instance, when you are starting with those who are newly diagnosed for TB for a particular period of time, alongside by 6 months to 8 months, some of them will get cured of TB, others will die of TB, others will default, others will get treatment completion. So it's more or less like a cohort. So all of them wear the same uniform of us, newly diagnosed of TB. They are diagnosed of TB, and you are observing them over time. And then there's an intervention. Treatment comes into play. So alongside others, even at the initial phase, they will be diagnosed at the lab. But because of the severity of the disease, before you even start with the treatment, they die. Others too, they will get on board and they are not adhering to treatment. They will just abscond. And then others too will comply and they will get well. And so I see that at the end of the day, when you are evaluating, because it's a cohort, a group of people with TB, you'll be able to evaluate at the end of the 6 months or 7 months or 1 year that this cohort of TB clients within this facility or this district, at the end of the cohort period, this number died, that number cured, and then that number also got well.
Okay.
And it's like I'm missing out. The other part of the question, sir. Prof.
Okay. Yeah, that's fine. That's fine. All right. The one of the key words I heard many people say was something about manipulation. The intervention is manipulated. That sounds like a straight textbook answer. Can someone explain to us in practice what that means? Because almost everybody mentioned the word manipulation of the independent variable. That sounds very technical. Like what does that mean in simple? How do you explain that so my grandmother can understand? What does that mean? And maybe the people who give that answer can clarify that too. Otherwise, somebody else can also answer.
Eugenia, your hand is raised. I don't know if it's both hand. And Oyedamola Samson. Eugenia, can you unmute yourself?
Okay, I actually raised sorry, I should have lowered it. I actually raised it when this question was put up, whether quasi is a purely experimental and all of that. That was when I wanted to contribute. But I think that has been taken care of. But this last question now, that or the meaning of manipulation, I didn't say it, but I think that what manipulation simply means is that somebody is somewhere trying to do the randomizing people, as in allotting or assigning people into the different groups where you have control, or maybe the treatment group, depending on the number of arms, is it 1, 2, 3, 4, and then the control group, meaning that somebody is actually there doing the allotment or the assigning. That's what I think that people refer to as manipulation.
All right, I'm going to describe 3 scenarios, and I want us to figure out what kind of study design it is for each of the scenarios. Scenario number 1, they're all going to be the exact same scenario with just minor changes. I, the investigator, I wish to look at the how does use of, let's say, ChatGPT, let's use that since that's a very common thing now. How does adoption, use of ChatGPT by students influence educational outcomes? I work with the Ministry of Education, get their consent, and we decide to randomize schools into, using ChatGPT somehow in the curriculum, or those that do not use ChatGPT in the curriculum. What kind of study design would that be?
Okay, Virginia, you can unmute yourself. That's a new hand.
Experimental.
Experiment. That's perfect. And in this case specifically, this is cluster randomization. That's what because we are randomizing people, not individuals, but entire schools, right? So there's cluster randomization going on there. All right, let's move on to scenario number 2. Scenario number 2 is that I come into this environment, and I met 2 years ago, the Ministry of Education had or let's go on with the second example first. I come into this environment and I find that some schools are, let's say in the US, let's use the example, the US as an example. School districts control, unlike in other countries, let's say in Nigeria, where you have a central Ministry of Education. Here, you have school districts control everything that is done in the school. So some school districts have adopted ChatGPT in the schools, others haven't, right? And my goal is to see how does use of ChatGPT influence educational outcomes. So I set out to compare schools that have adopted ChatGPT to those that have not. What kind of study? So again, this is the same research question. The research question is, how does the use of ChatGPT influence educational outcomes, right? But the devil is in the details here. We're looking at the nuances of the differences. In this second scenario, what design is this? So I come to the district and I'm going to follow students over time, over the next 3 years, 4 years, to see how both short and long-term outcomes will differ between the two groups. What design will that be?
Oyindamola Samson, you can unmute yourself and speak.
Okay, Prof, I will try.
Yeah, please go ahead.
I would say it is more of longitudinal experimentation.
Okay, but please, while I have you on the line, for an experiment to happen, what must be in place? What must happen for we to say anything is an experiment?
We must, for experiment to be in line, we must have the study area. 1.
Okay, before you move on, who assigns treatment in an experiment?
The investigator.
Okay, in this case, what happened? I remember I said who assigned people to us to did I really assign people to treatment in this second scenario? Remember I said that the school districts of their own had already made whatever policies that said this is how we're going to do things, right? And I'm just coming to see how students
Okay, you are not at, you are, it is the treatment on ground. That is what you want to check. So I think it should be observational. You want to try and observe within the two, like kind of observe. And then after observation, you can now compare the two results. What
So-
about that, sir?
Yeah, but that's very broad observational. That's not a study design, right? That's
Okay.
what kind of study design would that be? Remember, I said I met them on the ground, people who were exposed or non-exposed, and I'm following them over time to see how the educational outcomes down the road compare between those two groups. What design will that be?
Well, I really don't know what to say if I
Okay,
should say
that's fine.
it's.
All right,
What
we
about
can get help.
is it okay? Should I say is it a cohort study?
Yeah, it's a cohort, right? Because
Cohort study.
yeah, it's a cohort.
It's a cohort studies. Thank
Yeah,
you. Prof,
yeah.
I think I deserve something from you.
That is so funny.
I got it. I'm happy.
Yeah, so remember, a cohort study, essentially we're following two groups, exposed and non-exposed. They must be free of the outcome at baseline. So in this case, let's say we want to follow first year undergraduate students and follow them till they finish their bachelor's degree. At this point, at baseline, they are free of the outcome, right? And they're just exposed or non-exposed. It's not an experiment because we did not assign treatment. The school district, we just met them that way, right? The school district had already passed whatever, and we're just meeting them that way. Now, quasi-experiment is somehow in between the two of them, because we are the ones, that an intervention is being made, but people are not being assigned to it per se, because it's either that we are in a scenario where we can't really assign people, right? It's self-assigning. So let's say we're going to work with the Ministry of Education to set let's say in the US, right? We're still in the US where education is controlled by the school boards. We're going to work with some experts, in education and, computer science, and we're going to build an educational app, right? And we're going to leave it open. We cannot force school districts to adopt the application. They, of their own, can choose to say we will adopt it. So in this case, we have created an intervention, but we can't really assign people to it. We can't say, because we don't have the powers to do so. And sometimes another quasi-experiment is not just one thing. It's just that the assignment, there could be an intervention, but we're not the ones who are necessarily assigning it. But let's just stick to the example we're talking about. We've created this intervention, but the school districts can choose to adopt it. Some can choose not to adopt it, right? In that case, we're now comparing, at the end of the day, individuals who have adopted this intervention to those who have not adopted it, right? It is not exactly an experiment because we're not randomizing people. And it's not exactly a cohort study because we're part of the show here in this case. We have created intervention. It's just that we did not randomize it, so it's not a true experiment, and it's not a cohort study because we're not passive observers. We are involved in this, right? So it's neither here nor there. But ultimately, besides even just the terminology, what matters is ensuring that whatever design, right, we're doing, whether it's a cohort or it's experiment or whatever it is, we want to pay attention to threats to validity, whether they're internal validity threats or external validity threats. We want to make sure that we are aware of those and we can quantify them and control them. Because if you're not aware of them, then it's impossible to even try and control for them, in the first place. So that is how we want to make a distinction. So we need to understand this flow very carefully so that we can know where studies belong and we don't use the wrong terminology for wrong studies. Any other question before we go on to show how we can create some experiments on the platform?
Prof, there's a question in the chat box.
Okay.
The question is from Rabiu Salisu. He said, please clarify more on the issue of internal and external validity, sir.
Okay. So internal validity means internal validity has to do with the truth. So remember we said that when the whole point of doing a research study is to determine what is the truth, right? Let me exit this. So epidemiology is all about bias. So we'll talk about three types of bias: selection bias, confounding, and measurement bias. So these are the three types of biases we have in epidemiology. Every type of bias you know of falls into one of those three. Ideally, we want to get these biases down to 0, right? So internal validity is saying, to what extent have we achieved this? To what extent have we, well, it's impossible to eliminate completely all threats to internal validity. But to the extent possible, right? How close to 0 have we gotten in terms of eradicating all of these three biases? In an ideal scenario, right? When we design a study and we say that A is associated with B, it means that that statement holds true in the complete absence of selection bias, in the complete absence of confounding, in the complete absence of measurement bias, right? There is 0 effect of these three biases. That is what we mean by internal validity. Now, external validity is now saying, all right, this truth that you have given us, how generalizable can we take this truth and apply it to the other population, right? So think of it like as wearing shoes. Well, if I wear a shoe and it's perfect fit on my left foot, the question is it a perfect fit on the other foot as well? That's what generalizability is asking, right? Does it fit on both feet, right? If it does not fit, if it fits only on one foot and not on the other, it's like, well, it's not generalizable per se, right? But generalizability is not the end of it all. There's a reason why clinical trials are at the top of the mountain here, even though they tend to have low external validity. Well, it's because it's not every single time that we need to worry about a target population. The issue of external validity only applies when we are worried about a sample and a target population, right? And so in this case, we want to have results from this sample being inferred or being generalized to this target population. So this is the target population, and this is the sample population, right? The issue of external validity only applies when we have a target population we're worrying about and saying, oh, wow, these results that we have here, how generalizable can we move these results, or can we infer? But we also want to be aware that generalizability is not the end of it all. That's why we worry more about internal validity in general than external validity, because internal validity is saying, okay, this truth that we have found, how truthful is it really? Is it essentially, is it the whole truth, or is it the whole truth, right? Ideally, obviously, what we want is the whole truth, the truth with the W, right? Oops, this one here. That's what we want in general. We want the whole truth. But in the absence of where we have confounding and when we have selection bias, and when we have, what we end up with is a whole truth, the truth with holes, right? And that's not good, obviously. So this is what we mean by internal validity. How well is our study protected from selection bias, confounding bias, and measurement bias? External validity is saying, all right, and internal validity has to do with the sample, just sample, the data we've analyzed within the study. How well have we captured the truth? External validity is saying, all right, this truth that we've captured, is it generalizable to the target population? I think we spend a lot of time in epidemiology talking about generalizability. We don't necessarily talk a lot about transportability, right? Transportability essentially says that the results may not be generalizable. We may not be able to generalize from this to this, but they may still be transportable. Transportable means that we can still take some lessons from this result here and apply them to this population, even if they're not directly generalizable, right? So that's in a nutshell is the difference between, or distinction between, internal and external validity. All right, I'll take one more question and then we can go on to our demo.
There's no other question in the chat at the moment.
All right. Any last hands?
There's no
Okay.
hand raised.
All right, great. Yeah.
We
All right.
can
So,
proceed.
all right. So thank you very much. So, and we also must be aware of another thing that we need to be aware of is, especially for those of you who might want to do the business of research, is other types of experiments beyond epidemiology. Of course, epidemiologists are not the only ones who do research. You also have a huge world of market research, and market research is extremely important. So if you have even the remote idea or desire to do like run a CRO, a contract research organization, or get into the business of research, well, you need to know a lot more about research other than just epidemiological research. You also need to understand in depth about market research. And in the context of experiments, one of the things you need to understand is discrete choice experiments, right? Discrete choice experiments are used extensively in market research when we have a list of things and we want to see which is better. For example, let me show an example from what I'm saying. So here we have this this survey. This was a survey this was a study I did with a pharmaceutical company. They're interested to see what patients or potential patients, what do they consider as most important to them, right? So here the question says, you'll be taken through a set of screens which show a set of statements concerning potential improvements to HIV medicines, right? The idea is, which of these attributes do you as a patient consider most important? And as you can imagine, that is of importance to the company, because you don't want to be creating drugs that based on attributes that nobody cares about. You want to solve patients' problems. You don't want to be the problem, right? You don't want to create medications that become challenging to use or to take. So now you have a list of attributes: smaller pills, fewer side effects, reduced long-term impact on the body, less chance of affecting other medications, no food restrictions, less HIV medicine each day, longer lasting medicine. Now, what is the problem? Because we can simply ask this question like this and say, hey, please select which ones you think, or select which ones are most important to you. But what might be the problem of just telling people, select the top 2 medications, or select the top 2 attributes that you feel are most important, and you give them a list like this and you ask them to select? What might be some of the problems that you experience with that approach? Because we want to understand why discrete choice experiments are important. So we need to understand the problem that comes from just giving people a list and telling them, hey, can you just select whatever you want? What is the problem with giving people a list and saying, give me maybe the top 2 things you think are most important from this list? Any thoughts?
There's a suggestion. There's a comment on this chat section. Someone said selection bias.
Okay, what does that mean exactly? We should always use small words where we can. There's a reason why we have big words in the dictionary and we have small words. Small words should always be emphasized wherever we can. So what just in simple terms, what might happen when you give people a long list and just say, hey, select, what could happen? And I'm not even looking for a technical explanation, just from common sense, what could happen?
Okay, we have some people in the chat raising their hands. Abraham Koyara, you can unmute and speak, please.
Yeah, thanks very much. Others, out of intuition, they will just select something without thinking over it. The nitty-gritty about it. Others too, they may not be within a particular context where that thing is more or less they feel it much. So they say, let me just select something to represent something. In as much as some researchers, when you are carrying them out, others will say, once I take this thing, at the end of the day, I'll be scored higher, or I'm anticipating that the researcher will just say, oh, I'm in line. So therefore, I'm just giving responses to please the researcher or the principal investigator. But whereas in actual fact, because the person is not within the confines of what you are looking for, the person just provides responses that are just to please the researcher, and that's all. That is my take on that. Thanks.
That's very good. And why I have you on the line, what do we call that phenomenon in terms of measurement? What do we call that? Yeah, you're very correct. But what do we call it?
I want to give it a try. Whether can we term it as social desirability? I'm just guessing.
Well, sure, it's a great guess. Okay. Have you heard of the concept of satisficing? Let me type it down. Satisficing heuristic. So have you heard of this concept before? Because that's exactly what you. Okay, but okay, so that's the issue with measurements, right? It's a kind of measurement bias, right? Remember, we said all biases you could ever think of fall into these three categories. So satisficing heuristic is when, you know, the individual is kind of satisfied with the very first options they see. They're just too happy to answer and move on, right? And so you get answers at the end of the day, but the answers don't really reflect reality, right? So whenever you have a research topic that has to do with assessment of choice, you always have to worry about rank ordering, right? Because items are the order at the top, right? When you give people a long list of items, they're not really, nobody's really evaluating and saying, oh, wow, let me think intelligently about each of the options. They're just looking at the options at the top and saying, well, let me just move on with this. This is a very long list. So the question then becomes, how do you manage, you know, either order effects, because these are all related, right? You have order effects too, right? Order effects simply means that the order, as the name implies, the order of the items influences the responses. So in other words, the items at the top may be more likely to be selected just because their gaze is at the level of the answers at the top, right? When they get to that question, their gaze hits the very top questions, and so they become more likely to select those items, right? And so the order becomes, you know, influential. So what do you do? Well, you can randomize the order, right? You can randomize the order of the items so they're shuffled, so that there's no fixed items at the top or no fixed items at the bottom. So all the items are screwed, but everybody's screwed equally. That's the whole point. You know, in epidemiology, we are always worried about, you know, differential measurements. The issue is when it's differential, we want to have, this is what we want to avoid, right? Is when things are differential. We don't mind so much when it's non-differential. When if everybody suffers equally, we're happy, you know. The problem is when only a set of items are suffering the most. Like in this case, if you have a long list of items and the ones at the bottom are the ones that are suffering the most because nobody's showing them some love, well, then we become worried. We're like, okay, there's differential effects here because the questions at the top are more likely to be shown some love than the ones at the bottom. So, well, what do? We can randomize the questions. We can shuffle the order of the questions so everybody suffers equally, right? Now that addresses the issue of so the one solution to this could be to say, well, we're going to say select the top two treatments or the top two attributes that you think are the most important. Then we randomize the order. That's one solution to this issue. The second solution is to introduce a discrete choice experiment. It's called an experiment, not because it's a true experiment per se, but because, you know, it's one of those things that we like calling things experiments, even when they're not like true experiments. It's an experiment because the order of items or the order of attributes is shuffled, it appears at random. So on each screen, you have randomization of elements. So the one thing you need to know about discrete choice experiments is that you are always going to have a set of screens, right? That's why it says you will now be taken through a series of screens which show a set of statements. And on each screen, select the attributes as needed. Now, like, why do you need to know this? Well, if you are in epidemiology, you may never ever have to worry about discrete experiments or things like order effect. The moment you decide that I want to become, get into the business of research, I want to do work for corporations, or, well, you have to know all of these things. You have to know thoroughly everything about discrete experiments, because there's hardly a time you're going to do a study for a large corporation that they won't be interested in things that have to do with choice, right? Because at the end of the day, they run a business, and when you sell things to somebody, they are inherently making a choice to buy. So the question is always there, why do people buy things? Why do people buy this versus that? You will always have to worry about choice. You always have to measure choice and decision making. So you need to have a lot of expertise in measurements on things that involve choice and decision making. And so that's why discrete experiments become extremely important. So it may not be so important if you're just doing your regular epidemiological research, but in the area of market research is extremely, extremely important. And also knowing how they are presented. This is a paper, for example, which I just pulled to show analysis of data from a discrete experiment. So you can see preference shares for the 7 attributes of HIV medicines assessed. So you can see what percentage for each attribute. These are the 7 attributes: 1, 2, 3, 4, 5, 6, 7. For each attribute, what percentage rank them in first position? So you can see this is first position, second position, third position, and so on, right? Where's the legend? There's no legend to this. Well, that's a perfect. Okay, oh, sorry. There's a legend at the bottom here. My eyesight is horrible. So these are the legends here. First position shares, second position. So this is first position, second position, all the way to last position. So you can see that for this particular attribute, reduced long-term impact to my body, 23.3% ranked it in the first position, and only 3.1% ranked it in the last, as the last or the least important attribute. And when you look at smaller pills, many people don't think that's a major issue. Just 5.9% ranked it in the first place, and for 7.8% ranked it in the last place. The important thing about discrete experiment is also the analysis that can be quite complex. So, and that's one of the things the Chisquares platform does very well. It automates. You don't even have to worry about all of the complexity going on behind at the back of a discrete experiment, because all of that it's completely automated for you. So let's go ahead and see how you can set up experiments on the Chisquares platform, and how you can, let's say, analyze how you can, see how the platform analyzes them for you, so that should you be doing your own studies, you can figure out how to incorporate those as well. All right. Before my demo, any questions on the chat, Michael? Are we all set?
Yes, we have some questions.
Okay.
Someone said, Prof, would you please link the explanation with the sample size? That was talking about the internal and external validity.
Oh, okay. Oh, we're back to that. All right.
Yes.
Okay.
I should read all the questions, right?
Yes, just quickly read all of them, and then I'll see which ones to answer now, or whether we just push them to the end of the demo.
Okay, there's a question. Please, in a case I'm researching the sources of mass drug administration over time, can that research be regarded as cohort? Okay, I think that's all we have for now.
Okay. So the sample size issues are definitely part of internal validity, although that's not an issue of bias per se. That is part of type 2 statistical error, right? We tend to separate issues of bias from issues of error, right? Error has to do with something that occurs at random. Bias has to do with some things that do not occur at random. So when we talk about threats to internal validity, of course, we need to worry about biases, but we also need to worry about error as well. But we don't put error and bias together in the same basket because they're not the same thing. Error is random, while what do you call it? While bias is systematic. We can address issues of bias by addressing threats to validity. We can address issues of error by addressing threats to precision. So error always has to do with, to figure issues of error, we just have to worry about precision, right? And precision has to do with sample size, right? So that is the the solution to issues of bias. So in the case of sample size, like you asked, when we have, for example, a small study that is underpowered, right? We can end up declaring that, differences that exist in nature do not exist in our study. That's type 2 error, right? A false negative result, right? And that's not obviously true. If something exists in nature and you came out and say, well, this thing does not exist, that is not true, obviously. And that is a threat to internal validity that is from error, type 2 error, right? So in general, when we talk about issues of threats to internal validity, bias is a major thing we talk about, but we also don't want to ignore, error. Of course, the assumption is that, of course, the sample size has been done very well and all those other things have been met, and that's why we're just focusing on bias. But ab initio, you want to make sure that, everything is addressed. Your sample size is done correctly to address the issue of type 2 error. But it's not just type 2 error you have to worry about. You also have to worry about type 1 error. Type 1 error is just a fishing expedition. You are just looking for results. So you end up saying something exists when it does not exist. And that's where you solve that with a protocol. That's why we say you have to write a protocol. If you are a supervisor, your job is to make sure a protocol serves its actual purpose. Unfortunately, protocols have just become a routine mechanical exercise where we don't even understand why we're writing the protocols in the first place. The purpose of a protocol is so that I can hold your feet to the fire later on. So that when you now start making changes, I will say, no, this is not what is in the protocol. We need to adhere to the protocol, right? And that the whole reason why we're doing that is to avoid type 1 error, where somebody comes and like, oh, the results are not what I wanted, so I'm just going to go on a spree and look for results that I want, right? We avoid those with protocol design, and you write your protocol and you say what you're going to do, and we make sure we hold you to that, right? So we definitely need to worry about both bias and error, but we need to understand the difference between the two and how we address them. And then the second question I was asking, how I'm trying to find the difference between, sorry, I completely lost track of that question. Please, can you repeat that question?
Yes, I'll do that, sir. This, in case I'm researching the success of mass drug administration over time, can that research be regarded as a cohort?
Well, we don't know. We don't have enough information in that question to answer that question. Answer it. You're trying to look at the success of mass drug administration, but we don't know enough to determine whether it's a cohort or not. Remember, the issue is a cohort study is almost like a younger brother of a randomized trial. The only difference is who assigned the treatment. Now, that question of yours doesn't tell us who did that. Was it you in collaboration with the ministry, and you guys decided to randomize some people to a certain drug and others to a certain drug en masse? That's a different question altogether, right? As opposed to you just coming to a place and trying to see what the success rates are for whatever treatment the people are on as you met them. This one, you are not involved. So we need to know a bit more details about who administered the treatment before we can answer. And we also, yes, go ahead.
He responded in the chat already. He said the treatment is by the government alone, was by the government alone.
Okay, so if the treatment is by the government alone, then next question is, how are you designing the study? Because the treatment could have been by the government, right? And we come and give everybody a survey and say, hey, we're doing a survey to try and assess what treatment you are on and whether it works. Please, can you fill this survey for us? And then you ask them, what drug are you on? In the past 30 days, have you been able to, have you used the drug? Have you used, the substance? Or have you had thoughts about using the substance? Have you had withdrawal symptoms, right? I will collect data from everybody, and then we'll analyze our data to compare people who are on this drug versus that drug. Now, this is a cross-sectional survey we just did, right? That answers that question. We can also choose to say, all right, we would look at individuals who are rehabilitated, right? And we will then compare them with people who are not. And we'll look at shared factors or factors that differ between those two groups. That's a case control study. We can also choose to say, all right, we'll look at the fresh panel of individuals who have just been assigned treatment, right? And we'll follow them over time to see what happens in terms of the outcome here is that you come out clean, that you have quit using substance use, right? Now that's a cohort. Now there are so many ways you can slice and dice that with so many different types of study designs. So we still need more information from it. This is why you as an investigator must have a solid grasp of at least the foundations of epidemiology, because that same research question can be answered in so many different ways. So the broad idea of what you are trying to achieve is not enough. It depends on what you as the investigator can do, right? Because that's eventually what will determine the study design. All right, let's go ahead with our demo. So the demo is just two objectives. How do we set up, experiments on the Chisquares platform? And we're looking at under two scenarios. One is, a discrete choice experiment, and then maybe an online experiment where you're randomizing people to different media. And then we'll also consider a scenario where you might be randomizing people offline. Let's say you are actually giving them real treatment offline, and then you just want to collect data on the platform. All right, let's get started and see how that will work. So let's call this let's see, the effect of exposure to let's see, I'm very bad at coming up with just hypothetical topics. Impact of cigarette packaging. All right, so I'm trying to look at impact of cigarette packaging elements on perceptions of tobacco harm or harmfulness. Let's say my study participants are in Nigeria. And the aim is to evaluate the effects. Now, this is the few times where you can use the word effect when you're actually randomizing people, right? The word effect is a very holy word in epidemiology. It is the same word, it carries the same weight as cause. So words like effect, causality are reserved for when we are, estimating cause and effect, right? To evaluate the effects of tobacco packaging elements and how they influence perception of harm. My keyword here is packaging. And let's set this up. All right, I'll skip for now. I don't have a collaborator. All right, so now let's choose question type. We're going to start with a blank survey. And the first question type we're going to look at is the group allocation questions. So when you select group allocation questions, you'd see there are two of them here. One is the randomized trial. The other is the A/B test question. The randomized, both of these are experimental questions. The randomized trial question is designed when you want to randomize people to different media and ask them one question, right? So the question is the same. The question trying to capture the outcome is the same. What differs is what people have been randomized to. The A/B test question is when you want to randomize people to different questions entirely. let's say you are trying to look at a commercial, and let's say you have two questions that you want to test the performance of the questions before you include in your survey. And you're doing this particular study, you're doing just a cognitive, testing to look at how well the question performs. So there are two candidate questions. You want to randomize one half of the population to answer one question, and you want to randomize the other to answer the second variant. So in this case, you have two variants of the same question. So when you have multiple variants of the same thing and you want to test their performance, this is what an A/B test is in research. So the difference is, this is one question that you're looking at different media. This is entirely different questions. You want to see how performance varies when people are randomized to different variants. So let's start with this one, randomized trial. So let's say here we are trying to look at how people respond to different types of tobacco products that differ based on their packaging elements. So let us, first of all, upload the media we want to randomize people to. Let's see if I have media here. I typically have some. Except when I need them, then of course I can't find them. All right, great. Let's see, RCT images here. All right, so I have 4 images here. I'm going to call this, so the first one is an image with a red cigarette pack with plain text. Red, plain text. The other one is a red cigarette pack with graphic warning labels, like coughing. So I'm going to call this red graphic. So red text, red graphic. This is green text, and this is green graphic. So those are the 4 interventions that I want to randomize people to. And then the question, so it's a randomized trial here. It's an online media. So each person is going to see only one. There are 4 images, but each person will see only one image. And then the question could be, let's say, based on this image, how harmful would you, or let's just say, how harmful, or on a scale of 1 to 10, where 10, if you're providing a scale, always make sure you describe what that scale is. Where 1 is not harmful at all, and 10 is very harmful. How harmful would you rate this tobacco product? So that's the question here. And let's just label this as, and so let's see the preview on this. What question did I select? Let's use a sliding scale. So you can select, so you select this question format up here. So it's a randomized trial, but the question is what was the side dish? What question do you want to administer this randomized trial with? Yeah, and it can be any of these ones here. So in this case, I want to use a sliding scale. So I have to select sliding scale from these options up here. So, and this is why this preview button is good. So you can always see how the question will look like on the scale. So before you add it to your questionnaire. So now I am fine with this question. I'm going to push the questionnaire. So that's how you add a question that has to do with online randomization. The other way would be to let's add the other question types. Let's add an A/B test question, which is a multiple variant question. So again, this is also randomized. We're also randomizing people to these questions, but unlike in the previous example where each individual is asked the same question, the only thing that differs is the unit or the intervention to which they're randomized to. With this question type, we're doing something different. We are creating different variants, and each person will be randomized to the same variant. So let's say we are trying to test the performance of a question that assesses smoking. And we say, how would you, how will you define how will you describe your smoking frequency or your smoking behavior? Please select one option from below. So let's say we're trying to test a question that looks at the performance of two separate questions for smoking behavior, right? So let's say one option is I smoke rarely. Or let's say I never smoke. I rarely smoke. I sometimes smoke. I often smoke. I smoke all the time. So this is looking at, like self-reported frequency, or let's with adjectives, right? That describe frequency. Let's say you are trying to look at, you have a gold standard that tells us the prevalence of smoking in the population. And you're trying to compare two separate questions and see which of these questions provide the best, marker of smoking when compared to this gold standard. So here I have this one question that's asking questions based on this. And I want to add another variant. You can either create a new variant or you can import an existing question as a variant. Let's want to create a new one. Here we want to say, we want to add let's say a question like a single value text question that says, in the past 30 days, on how many days did you smoke cigarettes, right? Let's call this past 30 days. And so here, the user can then enter the value they want, like whether I smoked, cigarettes on one day, and we can say, let's allow only numbers. And the minimum you can enter is 0, the maximum you can enter is 30, so that we don't have to worry about data cleaning later. We apply that. If you have not smoked, if you did not smoke at all, please enter 0. So here we have two questions. One is looking at adjectives, the other one is looking at past 30 days, right? And the idea is to say, we want to compare the behaviors of these two questions without necessarily, because when you ask two questions, the problem is that these questions are not independent in real life. Once I have answered one question, it influences my answer towards the next question. And you don't want those kind of other effects to occur. You want the questions to be truly independent. So the only way you can do that is to randomize, those two questions to two different sets of people, so that one group answers one question and the other answers, and then you can then compare with the gold standard you have outside the survey. So this is what A/B tests are designed to do, to allow you to make those kind of comparisons. So in this case, the questions will be assigned at random to participants based on an algorithm created on the platform. So this is one case where we have one randomized trial, we have an A/B test. Now let's add another question that is also random in nature. That was an experimental in nature. And this will be ranking questions. Let's go to discrete choice experiment. So you come to ranking and you select discrete choice experiments. So like we mentioned earlier, this is a very, very important question. If you do market research, or if you ever think of going to market research, you need to know how to use discrete choice experiments in and out. And the Chisquares platform has really, really, really simplified what is a very complex process into something that is extremely straightforward. You simply enter the stem and enter the attributes, and that's all. All the other heavy lifting is being done automatically. So here you can say, please select which attributes, or please rank which attributes. I don't spell anymore. Most and least important to you from those displayed in the screens below, or in the screens shown, right? And then you list the attributes. So let's say small pills. Let's say costs of medication. I can't remember what the attributes were of the medications. I think we had longer lasting medicines and side effects. I believe that was also one of them, right? So let's just pick those four only. So you put the labels. The labels are what the variable names will eventually be. Small pills, costs, longer lasting, and side effects, right? So now we have created our attributes, and that's all. It's really, really simple. This is a process that is extremely complicated otherwise, but we've really simplified on the Chisquares platform. And when the users take the survey, the whole idea behind the discrete choice is that participants are not shown a long list, but they'll be shown screens, and on each screen you'll be shown 3 attributes where you can rank as top rank, middle rank, low rank, right? And that's how you have a permutation of items that covers everything. So let's just administer this and see how all of this works. So we've set our questions here. Now we have a randomized trial, an A/B test question, and a discrete choice experiment. If you had assigned treatment to participants offline, you can still collect data from them. That could just be a regular question. It could be a question like that says, let's create a question. Let's say you assign people to treatment offline, and you now want to just collect follow-up data from the 2 groups. That would just be any regular question. It could just be an MCQ or let's say, that says, how do you rate whatever the outcome it is you're measuring, right? And then you collect it, but of course you must have an indicator in the data set to know which groups they are on, right? That's the only way you can then be able to analyze that, in a meaningful way. All right, let's just launch this survey and just collect the responses and see how they look like when we take them. Let me quickly add a consent form to tell people that, we're doing an experiment and they should please participate. This is a consent form. I'll generate a default consent form, submit that. It's always a good idea for you to preview your survey before you launch it, so you see how participants will experience it when they take it. So quickly run the preview. So our consent form, this is the first question that we had, the randomized trial question. And so the image is loading. So please view the media below, then answer the question that follows, right? So this is, like you see, I've been randomized to just 1. I'll answer the question. how will you rate your smoking behavior? Please select one option from below. Remember that this was an A/B test question where we had two variants of the question. I have just been randomized by pure luck to this question, but I will only see one of it, right? And then this is the third question that involved discrete choice experiment where I have to select. All right, so that's my preview. Let me launch that and collect responses from you, and we can look at how they're analyzed. All right, so let me start my survey now and end it 2025. All right. And let me launch this. Okay, praise launched. Let me now share the survey link with you so that we can get some responses and see how they analyzed. And that will be the end of our session today. All right, so that's the link there. So you can take the survey if you are interested. And I'm trying to see if there are any questions that are on the chat that we could. Okay, there's a question. While you're taking the survey, I will just answer some of the questions quickly. How do the terms effects and impact differ? When should each be used? This is potato. They mean the same thing. There are some terms that are just secret to us in epidemiology that you should have a lot of respect for. These are cause, like cause as in CAUSE, cause, effect, impact, right? Those all mean the same thing. And most of the big name journals would tell you that you should kindly desist from using those names, right? Like the Holy Journal of Epidemiology, the American Journal of Epidemiology, for example. They have very strict guidelines on usage of terms. JAMA also has, let's see, author guidelines. So most epidemiology journals will be very strict with you on use of terms like that. I mean, every single epidemiology journal that is worth its salt will have detailed instructions on the terms that you can and cannot use. So for example, the journal discourages the use of the word effects in reports of single observational studies, right? And so on and so forth. The same thing applies to, just pick any random epidemiology journal. Most fields don't take those terms seriously, but of course, as epidemiologists, we take those things very seriously. And so that's why you'll find very detailed glossary of items, words that you just cannot use casually when submitting manuscripts to journals of epidemiology, because obviously we take those things seriously. Let's see if there are any other questions on the chat, which
there's another question, Prof.
Go ahead, please. Yes.
Yes, is in the chat. The person said, Isaac, he said, Prof, so once more, kindly, said, kindly mention the term that refers to the situation wherein respondents answer just for the sake of answering to please the researcher.
So we'll share this slides with you. So, but it's a heuristic. A heuristic, by the way, is what's the easiest way to describe it? Think of it as a mental shortcut, right? That's what heuristics are. Our human brains are very, very tricky. They lie to us all the time. So satisficing is a phenomenon, a psychological phenomenon where people just answer because, not because that is the actual truth, but because it's just easy. It's a heuristic, as I said, it's just a mental shortcut. And that's why that's the very basis for which we do discrete choice experiments. And we worry about these things, especially in the world of choice or choice analysis or decision analysis. And so should you if you're involved in that kind of work. All right. Somebody says, I was filling a survey on cigarettes. Oh, sorry, yeah. This is a very horrible survey, obviously. It's a demo survey, so I just packed a whole bunch of things. Oh, I see where you're confused. It's like the topic says impact of cigarette packaging. All right, that's a horrible topic because I just included the random topics in the same survey because it's just a demo, right? So that's why you have a question on pills popping up, because we're just doing it for the sake of demonstration. It's not a real survey. All right, let's look at the responses we have. All right, we have enough responses. So we can download the methodology report to see how the study was done. Let's see how. Okay, that's been downloaded. Let's also look at the analysis report for the whole population. All right, let's look at the download history and grab those reports, starting with the analysis report. So as we said, the questions in here are just dummy questions. The value of the exercise is not in the questions themselves, but it's just going through the whole procedure. So this is the title of our report, Cigarette Packaging Elements on Perceptions of Tobacco Harmfulness. This is our consent form. This is the randomized experiments that we did, right? Perception of harm. We can see that is in the, you can see it's obviously a continuous variable, so it's captured as the means with the appropriate deviations, which is the measure of variance accordingly. So the platform helps you analyze the data so that you can at a glance see how the intervention you are randomized to influences the outcome of interest. The next one was an A/B test. This is question 2, but since it's an A/B test with variance, we now have question 2.1, which is the first variant. And this is the responses we receive. And then we have the second variant, which was the past 30-day measure of smoking. And then we have the discrete choice experiment question here, and its analysis right here. And so this is to just give you a glimpse of how people rank the different attributes. So from here, we can see that the attributes that people rank considered most important will be the one with the highest first position place is side effects, right? You have a table here too that helps you, so you don't have to be trying to eyeball what the percentages are. This gives you a very exact value of the numbers here, but it's captured both as a graph and as a table. So in a nutshell, that's how you can design experimental studies on the platform. If there are any last questions, or answer them, otherwise we are beyond the time. All right, thanks everyone.
If you have questions, you can raise your hands. Prof is already leaving. Let me check. Okay, there's no hands raised. So I think we're okay, Prof. Okay, there's a hand. I got a hand. Abraham Kuyara, can you unmute yourself and speak?
Yeah, thanks very much, Prof, for your time and then the incisive presentation. There's this question I want us to look at. In case you want to look at the incidence of malaria among pregnant women vis-a-vis the administration of insecticide-treated nets and then that of SP, we call it sulfadozine pyrimethamine, pregnant women. So you are looking at it maybe within a particular period of time that this cohort of pregnant women who came for this time and then to the time they delivered, how was the incidence of malaria among such women in relation to SP and insecticide treated nets that were given to them? Please, Prof, is my question clear?
I thought you were framing the question. So what's the question exactly? I understand the context. You have...
Yes, I'm just creating a case scenario where we can couch something out of it based on what you have taken us through today. Please, do you get my point clear?
Like, yeah, you have a population of... So let me understand. You have a population of pregnant women. You have two treatments.
Yes.
One is a pharmacotherapy. The other one is insecticide treated nets. That's the context.
Yes.
Right? The outcome of interest is incidence of malaria. That's the context I got.
Yes.
So what's the question?
Sure. So out of this, we want to determine the efficacy that mothers who are giving these SP tabs and then that of the insecticide net. What is actually the effect? Is it acting as a protective mechanism in terms of developing malaria, which maybe will aggravate to anemia and then that kind of stuff? Then we just want to look at it and then maybe you measure the outcome so that you will maybe use it as a case study or a baseline to say, oh, within a period of maybe 2 years or 3 years down the line, this cohort of mothers came and they were given all throughout the year. These pregnant women were given SP, they were given long-lasting insecticide-treated nets. And when you just oppose it with that of the developing malaria and that of anemia, maybe the numbers are low or that kind of thing, or it's either high. I'm just thinking aloud in the context of what we have been taking through today.
So are you asking me which is more effective or what?
Yeah, like yes, but like what we have been taking through today, where we can skew it towards, yeah.
Okay, so
like you want to just get a study out of it to see what you have taken us through. That if you want to carry out this, okay, thank you.
Oh, okay. I think you've answered the whole question. You will have to decide whether it's a randomized trial or you have to decide whether it's a cohort study, or you will have to, that part, it depends on, is the investigator assigning treatment. And if you're the one assigning treatment, you assign. Obviously, for those kinds of studies, it's easier to do a cluster randomization because it becomes easier to say everybody in this community will receive mosquito nets, and everybody in this community will receive that. It's easier, logistically easier to to deliver that intervention like that. And then you follow them over time, collect data from them at maybe 2 months intervals or every month for 6 months, and you measure the outcome. That will be, I'm not even sure whether I'm answering the question at all, but that's one possibility to go.
Yeah, sure. That is it. But I just wanted to situate it in the context of the case scenario you cited about the ChatGPT issue, and then the students, the schools who were implementing this kind of ChatGPT. You came inside and you have seen that the intervention is already in place. So now you want to just carry out the survey and find out that, within this period of time, these schools were on ChatGPT, this is the outcome. There's other kind of schools, they were not also on it. But in this context, it's like more or less, we just have to situate it in a way where pregnant women who come to ANC frequently all things being equal, they may be given this kind of intervention. You are coming to observe and see. Then in a community where pregnant women may be there, but due to one or two reasons, they may not be going for ANC. And maybe that, in a sense, would be a comparative group. And that is just what I'm just looking at.
Okay. Well, that's your homework. You have to go and figure it out. I hope are you on our WhatsApp group? Are you in our village school group? And then come and share with us. So as a matter of fact, we should have you present next week. We will carve a spot for you 5 minutes at the beginning of next Thursday, and you're going to present to us. You're going to present to us the 3 possible designs, right? Actually, we're going to have like 4 designs from you. You're going to present.
Hey.
What different is
Probably roll it out to all of us so that we all come with our things.
No. Oh, we want your take.
Thank
So
you.
please, yeah. So prepare some slides. 4. It doesn't have to be a lot of slides. 4 or 5 slides that will show us what are the different ways you can address that same question with different study approaches, so that we can all learn from your use case. Does that sound reasonable? He has disappeared.
We have one more hand raised.
Okay, that's the last question we'll take. Sure.
Abisoye Oyeyemi, you can unmute yourself and ask your question.
Yeah, good day, Prof.
Hello.
Okay, thank you so much again. Sorry, please, I just need clarification concerning the use of this terminology. When you are doing a facility-based study, as compared to being in the community, is it appropriate to use the word prevalence? Like, okay, you want to find out maybe prevalence of malaria in a community where you have the denominator, you are working, you have a group that you have defined, but you are in a facility, and then all you have, is the number of maybe children that were treated for malaria, as opposed to maybe some other conditions, and you want to find out, okay, probably what's the proportion of children that were admitted for malaria? Is it prevalence or proportion? What should be the right word to use in that case? Thank you, sir.
What do you think? Why have you on the line? Please don't go. What do you think?
Well, knowledge I have, I think that, okay, when you're talking of the prevalence, you have a population at risk, and then you want to find out. But this one now, well, it's just the number of patients that reported. You don't know how many of them were actually suffering from that condition that were in that community where they come from. So I was thinking that, okay, it'd be better to say, okay, maybe proportion of children that are treated for malaria instead of using prevalence.
What's the difference between, it seems we may be having a challenge with understanding the difference between the proportion and the prevalence. So let's start from there. Who can help us understand the difference between the proportion and the prevalence? Any brave souls? And trust me, it's not a trick question at all. What's the difference between the proportion and the prevalence?
You can raise your hand if you want to answer this, so that I can unmute you.
All right, let's
There's no response.
No response. Okay, that's fine. Let me just go back to this slide here. So I'm interested in describing half of a population did XYZ or reported XYZ. Right. There are 2 ways I can say this. I can say,
Prof, yes. You're not sharing your screen.
Oh, I'm not. Oh, sorry. Thanks for flagging that. All right. All right. So this is what I'm interested in reporting. Half of the population reported XYZ. Right. Option 1. .5 of the population. Option 2, 50% of the population, what is captured in option 1 and what is captured in option 2? Remember, we're saying we're trying to describe half of a population, right? Reported XYZ. In one hand, yeah, I see one hand raised up.
There's a hand raised. Isaac, you can mute and ask a question and answer.
Okay, I think from the example given there, the 50% is actually prevalence, while 0.5 is a proportion.
So, we want to understand these three things, right? Proportions, prevalence, percentages.
I tried raising my hand, but my system misbehaved actually. I think proportion has to do with just a section of the survey, while prevalence is more sustaining, really.
Okay. So first of all, let's understand the difference between proportions and percentages. That's the first thing we want to understand. So when we express things as a percentage, that's obviously a percentage. Percentage means we take a proportion and we multiply by 100. So that's the first task we have to do. Know the difference between a percentage and a proportion. So who can now eloquently, based on what we have here, what is the difference between a proportion and a percentage? Because both of these are ways we indicate prevalence, right? So what's the difference? Based on what we've said, how does a proportion differ from a percentage?
Okay.
Or let's frame it this way.
Oh, okay. So
go ahead.
Sorry, complete a sentence. You're trying to make a point there.
No, so I was just trying to give you a hint that what is the range of a proportion and what is the range of a percentage? What are the lower and upper limits of the proportion versus what are the upper and lower limits of a percentage?
Okay. So for proportion, I think it would be around 1/3, 1/4 of the sample, while for prevalence it will be at least around 50% and above.
Okay. Any other thoughts? Thank you very much for your answer.
Yes.
Okay. Ben Onoja, you can unmute yourself.
Okay, thank you very much, Prof. I want to say that the proportion, the lower limit is 0, while the higher limit is 1.
Excellent.
And the percentage is 0, lower limit is 0, and higher limit is 100.
Excellent. So that's the difference between the proportion. And while I still have you on the line, do not go away, please. How do we convert a proportion to a percentage?
By multiplying it by 100.
Excellent. So this statement, someone saying this statement will be wrong. The proportion of smokers was 50%. It's like, okay, that statement is just wrong on so many levels, right? The percentage, the percentage ranges from 0 to 100. The proportion, so the proportion is just, it's like saying 100, you can say 1 naira or you can say 100 kobo, right? You're saying the same thing, right?
Yes.
So first of all, let's understand that percentages are 0 to 100, proportions 0 to 1. Now, there's this misperception also that you can only use the word prevalence when it's in the context of a population. That is false. This is, I'm not sure where this idea came from, but this is strongly from non-epidemiologic journals, or, I think this idea is very common in the social sciences, that if you calculated, a prevalence simply means of a population, what percentage have a particular indicator, whether it's new cases or old cases, right? Let's go back to this picture here. Prevalence simply means the combination of old and new cases, period, right?
Prof, you're not sharing your screen right now.
Oh, I'm not? Okay.
You're not.
Yes.
All right. I'm not sure why I keep doing that, but All right, so prevalence simply means, incidents and new cases that are dropping into the bucket, right? Prevalence means all cases, newer cases, old cases, those are all prevalent cases, right? And so we want to keep that in mind. So incidence means new cases. Prevalence means old and new cases in a population period. I hope that makes sense. If there are any follow-up questions on that, I would like to answer them.
Thank you, Prof.
Any other questions? The person who answered the question, I hope they're clear. They are clear. But at the end of the day, just stick to the nomenclature, and I understand that not all, some of these nuances are interpreted differently by other specialties. Of course, these are epidemiology concepts that are owned by us epidemiologists. Now, other people hijack these terms and use them different ways, which is fine, right? So my only encouragement would be that just stick to whatever language your specialty endorses. If your specialty or your field uses prevalence to only describe population level phenomena, that's fine too, right? There are different ways you can say, you can avoid using the word prevalence too, right? If that is not something that is endorsed in your journal. For example, if the prevalence, let me create a new document here. If the outcome was 50%, and you don't want to say, you don't want to say, am I sharing my screen now, right? Okay.
Yes,
Yeah,
your
yes,
screen
Prof.
is being shared.
Prevalence of outcome was 50%. Now, if that is a taboo in your field, there is really no need going against a discipline. I mean, you are too small as an individual to go against a whole discipline or a whole field. It doesn't matter how brilliant you are or how big you are in the field. So just stick with the field, the nomenclature of your field, realizing that different fields or the specialties interpret certain words differently, right? If you don't want to say it that way, you can simply say the percentage of the population that reported the outcome was 50%. See, we have avoided using the word prevalence. Or you can say in total, 50% reported the outcome. So we can say that in so many ways without using the offending word. If indeed it is an offending word, we can avoid using it. So at the end of the day, semantics like this really do not matter. What matters is that we are able to convey what we're trying to convey in a way that is clear to everybody without necessarily causing a fight. So just my encouragement would be that stick with whatever your discipline says, but know that epidemiologically, prevalence simply means this is why we always emphasize PICO. We're always talking about PICO as epidemiologists, right? PICO here means, P means population. Among your study population, the study population could be a hospital, it could be a community, it could be a whole country, right? Nobody said, nobody ever said PICO, the P in PICO must be a community or must be no. It could be just a health facility. It could be anything, right? As far as we define the P, then we're saying the prevalence is of that population, what percentage of old and new cases exist in the total population, right? But if this is considered offensive in your field, you can avoid it by just reframing things differently. All right. Thanks, everyone. We look forward to seeing you in class tomorrow for those who attend. Otherwise, we have one more question. I thought you said that was the last question.
Yeah. We still had more in the chat, like some people, and we have 2 hands raised. So in the chat, someone said, what about incidence? Is that different from prevalence? Then the second said, Prof, please, a brief comment about difference between prevalence and proportion. So those are the comments you have in the chat, the question, the comments.
Okay. All right, I will answer those. And If there are hands that are raised.
There are 2 hands raised.
Let's take all the questions and then I'll answer all of them.
Okay. Dr. Michelle. Dr. Michelle, please unmute and ask your question.
Okay, thank you, Prof, for this wonderful session. A quick question. You earlier mentioned that prevalence is combines both the new cases and the old cases. Now, if looking at the prevalence of a disease and we have both positive and suspected cases, now, especially those ones that were confirmed by the lab, and you want to get the true picture of the prevalence, do you consider only the positive cases, or you consider both positive and?
The line was breaking, but I think we get the point you're making. Okay, so questions were difference between prevalence and proportion. The second one was difference between incidence and prevalence. The third one was okay, what was the last question?
Those are the 3 questions.
Okay. We need the volunteers to answer these questions for us. So who can volunteer to answer the first one, please?
Please, you can raise your hands so that I can allow you to unmute. Okay, there is no hand raised at the moment.
Okay. All right. Proportion is just a way of, so we said earlier that we can express quantities that range between, think of the words naira and kobo, right? Those are ways of expressing yeah, we have a hand raised, Jamiu Bello.
Okay. You can unmute.
All right, thank you very much, Prof.
Jamiu Bello, you can.
All right, I'm speaking already. Can you hear me?
Yes, we can hear you clearly.
Okay. Well, based on my understanding of proportion and prevalence, I think proportion is a ratio where the Hello.
Yes, go ahead, Jamiu, please.
So proportion is kind of a ratio where a kind of fraction of a whole, while prevalence is like the proportion of a population that has a specific condition. That's the prevalence. Then proportion is just a fraction of the population that is under study, based on my understanding, sir.
Okay, thank you. So we need to understand that prevalence is both old cases and new cases. Let's establish that first, right? So prevalence is both old and new cases. Proportion is just think of it as a thermometer. A thermometer is just used to, or a tape rule. That's what the proportion and percentages, all they are serving is the tape rule. The only thing where you can use the tape rule to measure. I just realized I was on mute. Could you guys hear me at all?
Yes, Prof.
Okay. I'm not sure whether you heard all the things I said earlier. I just figured I was on mute.
We can hear you.
Okay. So I was saying that think of percentage and proportion as a tape ruler. A tape ruler can be used to measure anything. There is nothing special about what is being measured. So whether you're measuring the height length of your table or you're measuring the height of your chair, a tape rule can measure everything, right? That is what a tape rule does. So when you think of percentage or you think of proportion, think of them as a tape ruler. What it simply means is out of 100 people, how many of them have X, Y, Z or X? X could be anything, right? So let's take two scenarios here. Scenario number one, we have let me look for, all right, let me just draw this out. Like, so scenario number one, we are doing a longitudinal study. Let's say we're doing a cohort study, right? Year one, at baseline, remember, nobody has the outcome of interest. When we come back in year one, we realize that 50 out of 100 have developed the outcome, right? So here, what metric are we talking about? Is it incidence or is it prevalence? I'm going to answer these two questions together. So again, remember, we're trying to do a longitudinal study, or let's say cohort study. This is year one. We came back just the first follow-up, and we realized that of the 100 people who were disease-free, 50 have developed the outcome, which as a proportion is 0.5, or as a percentage is 50%, right? Is this incidence or is it prevalence? You can unmute yourself and answer if we have, let me see who is, so great. We have incidence, right? Now, we are using proportions to measure. So again, we want to take what I'm really trying to emphasize here is that proportion and percentage are nothing, are nothing special. They are just a tape ruler we're using to measure the things. In this case, we're using these tape rules to measure what? I'm not sure what's happening, but I'm not sure if you guys can still hear me clearly. Can you, if you can hear me clearly, can someone confirm? Can I get a thumbs up if you can hear me clearly? Otherwise, this might be the universe telling us that it's time to close the day. All right. Okay, great. So in this case, right, I mean, again, the take-home message is that a proportion or a percentage are two sides of the same coin. One is just from 0 to 1. The other one is 0 to 100, right? And they are just, think of them as a tape rule. There's nothing special about a tape rule. You can use a tape rule to measure anything. So in this case, we're using this tape rule to measure incidence. Now let's come back, let's say we come to year two, and we find that 60 people together, both from year one and year two, have the outcome, 60 over 100. Now we can say that the percentage that have the outcome is 0.6 or 60%. Now we are using proportion and percentages time to measure what? Who can answer? You can type the answer in the chat. So remember, in year one, we're measuring incidence, as you all said. But now, this number, we only say 60%. Is this measuring incidence or is it measuring prevalence? Exactly, we're measuring prevalence now, right? So the take-home message is that there's nothing special about percentage or proportion, right? They are just a tape rule we can use to measure anything, whether it's mortality or whatever, right? There's nothing special about them in of themselves. And that's why we have separate terminology that like incidence or prevalence, separate from percentage and proportion, because some are epidemiologic measures that are just ways of capturing, constructs. And so these are agnostic of what is being measured. I hope that difference is clear. So yes, and then the last question was the difference between suspected, probable, and confirmed cases. So in this case, this is why we have case definitions, right? This is the importance of case definitions. You can say we described, a suspected case, or we describe cases as individuals who had either who met probable or confirmed definitions, or it depends on how you define it, right? But that is why we have a methodology section. So in this case, this particular question is very arbitrary or very subjective, because it's however you define the outcome of interest. You might have defined it as individuals who met definition for suspected, probable, or confirmed, or you might just have defined it as individuals who were confirmed, right? So this question number 3 is entirely up to you in terms of how you define the case. So I hope that is clear. All right. I think there are no further questions, so we can call it a day today. And we have a class tomorrow talking about case control design. So if you are ever interested in gaining expertise in case control designs, you should definitely attend tomorrow's class. Otherwise, we'll see you Thursday next week. Thank you very much, everyone. Michael, are you still here?
Yes, I'm here, sir.
Okay, all right. All right. Thanks, everyone. Bye.
Bye. Thank you, Prof.
Yeah, thanks.